Hello students, welcome in the revision session of third lesson current electricity of 9th standard. If you go through the exercise, we having the first question. What is first question? They have given one diagram or a portrait of different application, that is the domestic application or appliances have connected within the circuit, and the questions are based on this one. See, within the first question, which one is the first one? The first question is, by which method are the appliances connected? Here we having the domestic circuit, and within the domestic circuit, to maintain the equal potential difference is very important. So all the appliances have connected in parallel combination. So all the appliances, TV, then we having the table lamp, we having the fan. Within the domestic circuit, all the appliances are in parallel combination. Second one, what must be the potential difference across individual appliances? See here, we having potential difference in the domestic circuit, that is potential difference in between live wire and neutral wire, always 220 volts. And so within the parallel combination, potential difference will not change as per the circuit. So potential difference across each and every individual appliances is, that is PD, that is equal to V, is equal to 220 volts within the individual resistance or within the individual appliances. The third question they have asked to us, will the current passing through each appliances be the same? No. Why answer is no? See, here current is inversely proportional to resistance. So more the resistance, less the current. Less the resistance, more the current will flow. What is resistance? Resistance is a capacity of that wire to oppose the current. So if the capacity is more, current will go little. So here the appliances with more resistance has, or we should consider have, less current. Got the point? Or they will drag the more current. What is the third one? Why are the domestic appliances connected in this way? Why it is necessary to connect this one into parallel combination? See, one thing, when we are going to join many appliances, each and every appliance or each and every equipment should get the same potential difference. So potential difference maintains same only in the combination which is parallel one. And again, by applying the parallel combination, as you are going to increase the resistance, effective resistance get reduced. So what is the first one? To reduce effective resistance. And the second reason behind this is to maintain equal potential difference. So that is the reason behind this one. So within that, the last question, if TV stops working, will other appliances also stop working? No. Answer is no. Why no? Because each resistor or each appliance has connected separately in parallel combination. So that is the answer for this one. And as each appliance has connected separately, if one of that is not working or out of order, then second one remains in working. But if you attach all this one into series combination, if one get diffused, definitely other also get diffused. Question number 2. they have given one incomplete circuit, and along with this they have given different components of a circuit and asked question, how will you use this within the diagram and what is the law which can be proved with the help of this diagram. See, what is the first one? What we want when we are discussing this circuit, we want battery to maintain the potential difference. So which is that battery here? See here, this one is a sign of battery. So we are going to use it here. This is a battery. Clear? So it is a positive end, this one is negative end. To stop and start the current, what we need? We want one key. So we are going to apply the key here. Getting? So as current is flowing, how much current you want? To maintain the current or to maintain this one, we want rheostat. So here we are going to join the rheostat. This one is a rheostat we have applied here. Next one. So how much current in the circuit? To measure this one, we want, that is ampere meter. So just ampere meter we are going to join here. Positive end is towards positive, negative end is towards negative, because electrons are flowing like this one, so negative to positive. Then we want to measure the resistance of this circuit. So here we want resistance. This is a resistor we have joined here. So what is the potential difference in between this one? To measure this, we have joined here one voltmeter. So see here, voltmeter, positive end is towards positive, negative end is towards negative. So all the components we have joined here. So what is the answer? Next one, which law is get proved? And the answer is which one? Ohm's law. Question number 3. One user is given a mesh, and within the circuit he is using two bulbs. The first bulb is of 15 ohm and the second bulb is of 13 ohm. If he is using the bulb individually, the filament get burned. Why? Because current is more. So when current is more and resistance is little less, more heat get created, and because of that heat, that filament within the bulb get burned or it diffuses. So what is the need of this occasion? To increase the resistance. He is having two bulbs, but suppose if he is using that both the bulbs in parallel combination, again effective resistance get decreased. Then which kind of combination he has, you will suggest here. So see here, need is to increase the, what is the need? Need is to increase resistance. Getting? Therefore, he must use which combination? Series combination. So that is the first answer. Okay. What is the characteristics of this combination? That is the series combination. See, within the series combination, one thing is here, current is same. Current will be same. Got or not? And again, if you are going to combine this both bulb in series combination, effective resistance increases. Effective resistance increases. That is the characteristics. Okay, third one. What will be the effective resistance? Yes, we having the formula R1 and R2 have connected in series, and as we having the formula, that is Rs is equal to R1 plus R2, that is equal to 15 plus 30, that is equal to 45 ohm. That is the effective resistance of this combination. Circuit, how much potential difference they have used? and due to this potential difference, what is the current within the circuit, this information they have given. And the first question they have asked, what is the average resistance? See here, within the first condition, we know that when V divided by I, that is equal to R. So for first example, R1 is equal to V divided by I. What is the value of V? 4. Here divided by 9. Answer is 0.44 ohm. So within the second example here, 5 divided by 11.25. So that is also we having 0.44 ohm. Calculate this one. Then third one, again it is, that is V divided by I, that is 6 divided by 13.5. Answer is again 0.44 ohm. So what is the average resistance? So average resistance I am writing VA, that is RA, that is equal to first R1 plus R2 plus R3. So as it is average, addition of 3, division is of 3. So 0.44 plus 0.44 plus 0.44 divided by 3. So that is 2 into 0.44 divided by 3. So 3 get cancelled and we are getting 0.44 ohm. So that is the average resistance we are getting of this experiment. So second one, what will be the nature of graph between current and potential difference? See, as ratio is constant everywhere, definitely what is here, the current in the circuit is directly proportional to volt. So if without drawing that one they have given, when we consider here current and here potential difference, so wherever you go, graph is linear. So what kind of graph we are getting? We are getting here linear graph, that is the straight line we are getting. So the next question they have asked within this one, which law will the graph prove? Explain the answer. And answer is, this graph is proving what? Ohm's law. What is the Ohm's law? If the physical states of a conductor remains constant, which are the physical states? Length of a wire, area of a cross section, then the temperature, getting, and last one material. These are the 4 physical states. If constant or remains constant, then the current I flowing through it is directly proportional to the potential difference between its ends. So that is, I is directly proportional to V, current is directly proportional to potential difference. So this is the answer for question number 4. Now question number 5. What is question number 5? Match the pair. What is the group A? Free electrons, current, resistivity, resistance in a series. So first we are going to discuss free electron. What is free electron? The free electrons which are loosely bounded. Loosely bounded means what? Weakly attached. So this option is correct. So for one option, correct option is C. Second, current. See here, we having V divided by I is equal to R. That is here V is directly proportional to I. So V divided by I is constant and this constant is resistance. So see here, if V is for division, V is equal to I in R into I, it will transfer for multiplication, and now this will transfer for division. So V divided by R is equal to I, that is current. So what is current? Current is equal to V divided by R. So where we having here? So for second option is A. Now what we have? We having resistivity. See, what is meant by resistivity? We have discussed that resistivity. Okay, leave that one. Now resistance in a series. What is the characteristics? When resistance in the series or resistors have connected in series combination, effective resistance increases. So increase the resistance in the circuit. So here option is B. So only one option is remaining here, which is that one D. But how it is, that we are going to discuss now. See here. What is resistivity? Rho is equal to R into V, R into A divided by L. That is the formula we having. What is resistance is equal to, resistivity is equal to resistance into length of a area of a cross section of a wire divided by length. So what is R? Just we have discussed, it is Y divided by what? V divided by I. So into A divided by L. So what is the value we are getting? VA divided by IL or VA divided by LI. What will be the differences? So where we having this one? D. So option D for the third is correct option. The resistance of a conductor of length X is R. So see what is given for us. What is given? Resistance is given. Resistance is equal to, generally we are using R and that we having R. So second one, length of wire, we are generally using L, but here we having X. Then area of cross section, area of a cross section, generally we are using A and here we having A. Then they have used what is resistivity. So rho is equal to question mark. So what is the answer we having? Rho is equal to resistance into area of cross section divided by length of wire we having. So what is R? R is small r. So area of cross section we having A and divided by what? We having length of a wire is X. So finally we are reaching here RA divided by X. So this is a formula. This one is a resistivity of this resistance. So what is a SI unit? So we having here SI unit of resistivity. How? See here. Ohm. Here meter square divided by length is also in meter. Got or not? So this square and meter get cancelled. So finally we are getting the answer. Resistivity, SI unit of resistivity is which one? Ohm meter.